Let's continue. Lex 23e, cancellations, 16 terms. Now this definition, in this case, is the abstract definition of the Riemann curvature. Okay? We'll say these 16 terms here I just copy from lecture 23D. You see, it's the same over here, the same 16 terms. 7 here, and 2 over here. You see, they're the same. Now let's continue, okay? There on lecture 23D, we construct group 1, 2, 3. And then to continue, now I move to group 4 on this lecture. Terms with partial of Christoffel symbols. You see, I just copy from here, you see, and then I write over here. This is, this case, the 1, 4 and 2, 4. This is plus and this is minus. You see, I would like to emphasize that here I don't want to cancel. I could, but I don't want to do it. I could because I can swap I and J. But I want these to remain, okay? They will remain, they will survive, okay? Unless if I want to cancel, then I swap I and J. But I don't want to do that. I want to remain, they remain these two terms here. So, the same in the group 5, terms with gamma, in this case is a Christoffel symbol, partial of Z. Here is only Z, this is partial of Z. Then I copy this from here to here. This is, this case is 1, 5 and 2, 5. This is plus, this is minus. Again, I could cancel, but I don't want. I would want to survive these two terms because I want they to remain. Okay, this will remain, this will remain. Now group 6, terms with, in this case, Christoffel symbol partial of Z. I just copy this 1, 6 and this is 2, 6. Okay, I just copy from here. You see, you already have this list. And then I write this term 1, 6 and 2, 6, plus and minus. These remain, okay? So they also survive. Okay, group 4, 5, 6, okay? They survive. They don't, I don't want them to cancel. But group 7, terms with, this is double Christoffel symbol Z, okay? I just copy from this list. This is 1, 7, 2, 7. This is plus, this is minus. These remains survived. Now, attention now. Now I'm moving to the step 3, okay? This over here is step 1, okay? And the step 2 now is step 3. In step 3, I have this case, the final 5 surviving terms. Number 1, this number 2, number 3, number 4, and number 5. You see, they are the survived terms. And just copy, okay, from here to there. So the first, attention now, the first 4 terms in this are linear in ZR. You see, I have ZR over here, ZR over here, ZR over here, and this R over here. You see, these 4 terms, which is linear, okay? Now, you know what means linear transformation. So that's, but on the other hand, the term number 5, xi, yj, you see, they are not linear terms, okay, on ZR, because here I have the derivative of ZR, so they are not linear, see, as I pointed out over here. The last 2 in 5, okay, in this case, okay, you multiply partial of ZR. You see, that's why they are not linear, okay? Now, step 4, okay? Match with the standard Riemann definition. You see, now the tensor, which if you work only with the 4 survived terms, okay, this term over here, this I emphasize that only 1, 2, 3, and 4 that we are used to define, to match the Riemann curvature tensor. So, and the 4 terms involve only ZR, you see, which is a linear term, give the standard form of the Riemann tensor. You see, when I compare this with the standard definition, I see that only the linear terms, okay, will match with the definition, okay, the standard definition of this case Riemann curvature. So there's the same here, Rm, Rij, you see, and these are, I just repeat, I just copy from here and that's right over there, okay? Now you see here, you count here, 1, 2, 3, in this case, you have 1, 2, 3, and 4 terms, okay, which correspond to the linear terms, okay? The term which does not correspond to the linear, okay, is item 5, which is this term over here. So that is why Riemann curvature by the standard definition, you see, this case only capture the linear part, the linear part in the R. So this is a standard definition, okay? This R here is the same as I obtained from this case for the definition, the abstract definition. So the abstract definition must match the standard definition. You see, it's not the opposite. You see, that's why these nonlinear terms, okay, they are eliminated just to match. Otherwise, if you consider, for instance, item 5 over here, okay, this here will not match the standard definition. That's clear, you see. Again, to match the standard definition, okay, the abstract, okay, must neglect, okay, forget the item 5 over here. You see, that's a clear consideration. This here, unfortunately, we don't see as clearly as it is, okay, in the literature. Okay, they just pick in this case, okay, the abstract definition, okay, and apply this, okay. But now you know, okay, from where I can consider this, in this case, the abstract definition, just to calculate, okay, to apply it to intrinsic geometry, okay. That's a very important issue, okay. So it's clear for you, okay. Again, just to finalize, you see, in this case, okay, the abstract definition, okay, must be match to this case, the standard definition, and not the opposite. Okay, again, just to emphasize, that's why we eliminate, okay, the nonlinear term, okay, just to write, in this case, the abstract definition. Clearly, you see, that's it.